Very good evening to all the attendees and to our panel. My name is Rohit Thakur. I'm the manager in sales and operations for FirstUniv. Today's session is very interesting. We are talking about deep learning for the field of healthcare, right? When I talk about us as an organization, as FirstUniv, we try to keep in teaching our students, teaching our learners every weekend. That's why we conduct all the sessions. Those of you who have not attended our previous sessions, please check out our website and please go through the YouTube page where you can get insights about very interesting topics which we have covered in previous sessions. Right. Today's session, when I talk about, it is about deep learning. I've already talked about deep learning for healthcare. As we can understand, AI, with the increasing popularity of AI, we have abundance of data. In all fields itself, and in field of healthcare, it can be a gemstone kind of a thing, right, which can be used for to understand so many different insights, and which can be helpful in diseases such as diagnosing cancer at earlier stages itself. So talking about this, taking you on the journey of healthcare, we have with us Dr. Professor Gaurav Gupta, sir, right? He's MTech, PhD, CSC Machine Learning. He's the senior member from IEEE, serving as an assistant professor at Yogananda School of Artificial Intelligence, Computers and Data Sciences, Faculty of Engineering with Shoolini University. Also, his PhD and he's done his PG and PhD from KSOU VIT Karnataka and Shoolini University. He's very known in the field of this healthcare and agriculture. He's published 12 books, both nationally and internationally. So I'll welcome him on the podium, and he'll be talking about deep learning, which can be used for healthcare itself. So we are very honored to welcome you, Dr. Gupta. You can continue.
Thank you, Rohit.
Thank you.
Give me a sec. I will share my screen first. I think it is visible now.
Yes, yes, Dr. Gupta, you can continue.
Okay. Hi all, welcome to the next series of lecture, that is deep learning in healthcare, and myself, Dr. Gaurav Gupta, welcome you here. So why should you bother about this deep learning thing? Why bother? We have a number of things line up in today's scenario, that is like machine learning, AI, deep learning. Why deep learning? As the data is increasing on the day-by-day basis, numerous data, supervised or unsupervised, and all kind of data, that whether it is text, image, so the processing of the machine should also be increased. That's why we are using deep learning right now. As per the research perspective, 500 plus papers regarding deep learning and medical image analysis have been published till yet. So topics for what are the agenda of today's, we will go for the introduction of deep learning in journal. What is deep learning? Why now? Deep learning in healthcare particularly. What are the different challenges faced while we work in deep learning, particularly in the healthcare sector? And the conclusion and the key takeaway from the lecture itself for the today's scenario. So as we go on, so let's start with the introduction of AI, what is deep learning and all. As you're all aware, what is artificial intelligence, what is machine learning, what is representation learning, and what is deep learning. For the sake of your people, machine learning is distinct from other type of computer programming in that it transforms the input of an algorithm into output using stats, data-driven rules that are automatically derived from a large set of examples. That is a general machine learning thing. rather than being explicitly specified by humans. Means constructing a ML system required domain expertise. These are the domains like deep learning and other machine learning. These are the domains in particular AI and human engineering to design feature extractors that transform raw data into a suitable representation from which a learning algorithm could detect pattern. So in contrast, what is deep learning to machine learning is a deep learning is a form of representation learning in which a machine is fed with raw data and develops its own representation needed for pattern recognition. This is composed of multiple layers of representation. We use representation learning also in deep learning. These layers are typically arranged sequentially and composed of large number of primitive non-linear operations, such as representation of one layer is fed into the next layer and transformed into a more abstract representations. As the data flows the layers of the system, the input space becomes tentatively wrapped until data points become distinguishable. That is about machine learning. This is the, as I talked to you, input data, a hidden layer 2 means the output of first layer will become the input of the other layer and so on, and we will receive the output in the same manner. This is a simple multi-layer neural network, takes two classes of data denoted by different colors and make them linearly separable. These are linearly separable. We have two classes of data. We are making them linearly separable and getting a single output. The final output layer serves as a classifier by outputting the portability of either one of the classes. Means either, as we take the example of cancer or non-cancerous, we have to devise either the input is cancerous or non-cancerous. That is the main point. And second one is deep learning. On the contrast to the machine learning, this is the deep learning. This is a large scale network that accepts and input a variety of data types like image, temporal inputs, multimodal inputs. Means we can use time series data, image, textual, any of the data. And for each data type learns a useful featureization in its low level towers. These are the low level towers. It will learn the features of the inputs, input hidden layers 1 and 2. And then we carry on with the hidden layers. We can add more hidden layers to this particular network. And the data from each tower is then merged and flows through higher levels, allowing the DNN to perform increase across data types, a capability that is increasingly important in healthcare. So deep learning is not new. So what happened? What we have done? This is not a new field. As we have grown the data, as we have increased the hardware resources, and we are working on the algorithms, the new techniques are evolving. First, we are working on machine learning. Then we go for first we are working on AI. Then we go for machine learning, reinforcement learning, supervised, unsupervised. Now the deep learning. As we have the numerous type of data set, as I have told in the previous slide, that as the data increases of the unlabeled data, then we are into the different type of hardware and algorithms. So deep learning in healthcare examples. Now what we are talking about, this is the main topic. What is the deep learning in healthcare examples? This is a medical imaging. Deep learning in medical imaging. This is an example of a normal CNN that can be trained on a variety of medical imagery, including radiology, pathology, dermatology, and ophthalmology. These are certain medical terminology that I am using here. Information flows from left to right, from here, from input to the output, from the softmax to the output classification. For example, this is a n type of input. This is a cancerous, this is eye, this is a body scan, MRI, any type of input you can take. We will go for the CNN pooling and then we go the activation function like softmax, and in the end we will classify whether a person is a cancerous or non-cancerous, whether he's suffering from COVID or something else, whether he has a eye tumor or not, or brain tumor or not. These are the medical imaging. By the help of these images, we can classify the things. The element of the output vector, what is the output vector? Means the softmax layer represents the probability of this presence of disease. This is the part which give you the exact whether the disease is present in this particular image or not. During the training process, the internal parameters of the network layers are iteratively adjusted to improve accuracies. We can adjust these type of poolings and convolutional layers to increase our accuracies. Typically, lower layers learn simple image features, edges, and basic shapes, which influence the high-level representations. Prediction takes prediction will include both the classification of the images as well as the localization of medical features such as tumors, as we have talked in this particular image. This is the particular example of pneumonia detection on chest X-rays using DL or deep learning. You are well familiar of these terms like cardiology, infusion, pneumonia. Latest to the pneumonia is the COVID-19. We usually detect COVID-19 with the help of chest X-rays. As this is the lung type of disease, we usually detect COVID-19 with the help of pneumonia detection or CT images or MRI images. This is an example I have taken from the source for the chest X-ray in 2017, preprint by Rajpuran and Pranav. They have achieved the Evans score of 0.44. That is a good one, accuracy of 95%. Second, making predictions using EHR. Then what is EHR? Why we are talking about EHR? EHR is the electronic health records. As we talk about healthcare, healthcare is not only involves the prediction or diagnosis, it also involves the keeping the record of the patient. In that field also, we are using the machine learning or deep learning part, as the data is always unstructured. We have the MRI, we have the CT scan, X-rays, the prescription of the medical practitioners and all. Means here the image are divided into the four categories. Like the first part is the unstructured EHR data. These are the unstructured EHR data, means image, text and all. Medical records are stored in iodinized data structures and formats such as model built on a given hospital record do not necessarily work with the data from a different hospital. Means data will differ from hospital to hospitals. One hospital might be working for the only for the CT scan or MRI or the lab pathologies. One hospital might be working for eye nowadays, or kidney or something, or heart specialist. So data will be on the hospital to hospital basis. Second part is the data standardization. This is standardization of the data. How you standardize the data? By mapping data from multiple sites to a single format based on FHIR. Means data are standardized into a homogeneous format. Means particular format that can be used by across the hospitals. Third one is sequence. Sequence is a sequence model have access to the entire patient records. Means from entry of the patient to the leaving of the patient from the hospital, we have the entire entry record, and also the history of the patient, what he is suffering from in the previous sequencing. By temporarily sequencing all data into a patient timeline. Timeline-based deep learning technique can be applied on the entirely on EHR data sets for making prediction about single patients. Means what part of a patient past history should be reviewed, what we have to see in the previous histories, what about a patient current state needs to be known, and what are the opportunity to intervene. These are the deep learning tasks what we are going to adopt from these three scenarios, and what are the risks of future outcomes. That is the prediction of deep learning by taking into account the image, the health record, and the sequence model what we adopt for deep learning. And in the case of this one, we are taking the example of classification of skin care using DL. Cancerous hospital which are only going to treat the people who are suffering from skin cancer. They again have taken this reference from the Nature, that is written by Andre. And these are the dermatologists. There are three type of images we have taken, that is carcinoma, melanoma, and melanoma dermatologists. These are dermoscopy. We have taken these type of three images, and we have a different type of accuracies into the three of them. Means the other three type of cancer we usually find in skin. Means carcinoma, the accuracy comes out to be 96%. That is very important, because you see, as the pollution is increasing day by day, we are suffering from skin type of diseases, and that prone to be cancer. Now we in deep learning, we are also working on such type of images. And second is melanoma. We have the author has received, the researcher has received the 94% of accuracy here out of 130 images, and the sensitivity of for the dermoscopy images, melanoma is 91%. Means that this is the highest level of accuracy that have achieved by the researcher here in this one. Now, what is the main in biology? What we are doing in biology? Why the ML in genomics? ML means deep learning in genomics. What we are using into this one? I had divided this picture into the four categories, means the input data, the example data tensor, DNN, and biomedical aspects. Means input data can be transformed into a data tensor that can be used to train the DNN or CNN or DL type of algorithms that we have talked about previously, and that can be used for biomedical applications. Means we have an input data such as like genomic data consists of experimental measurement from which certain properties or outcomes of interest may be predicted. Medical, sorry, medical record, clinical validation, pedigree, test results, gene conversations, and amino acid sequences. These are type of genome sequencing what we are talking in this. The data is often diverse and may include sequencing, gene expression, and multifunctional data, as well as other forms of molecular data. Second is the example data tensor, means raw experimental measurement needs to be transformed into a form that is suitable for consumption by deep learning algorithm. Means we can't take any type of sequence or string into a deep learning. We have to convert that string into a meaningful information. We have to pre-process the data first. We can't directly give the output of this genome sequence to a deep learning. We have to convert or pre-process the data first. We takes an input multi-dimensional data tensors and associated target labels. We have to label the particular genome. The next one is DNN label, means we have the label tensors are used to train DNNs to predict the label from the input data tensors. What we are talking about, we have to predict from the tensors. Next is biomedical applications, means pharmacogenomics, molecular design, DNA sequencing, experimental data inputs. We are talking about this into, means the trained DNN can be used in biomedical applications such as in predicting labels for previously unseen data tensors or examining the relationship between input data and the output labels. Example applications like interpreting experimental data, inferring DNA sequencing from the output of a sequence instrument, or such as DNA mutation or gene splicing, or molecular diagnostic, predicting the effect of genetic mutation on disease risk or drug response, among many of the others are also there. This is the example for the another example for DL in medical imaging, like arrhythmia detection using DL. We are again taking the example of Pranav. Pranav has done a commendable job in this particular field. You can also go through our research papers into this field. Means the cardiologist level arrhythmia detection with convolutional neural network. What is arrhythmia? Why there is a irregular ECG signals when we are getting into this one? Why 34-layer convolutional neural network have been used for this arrhythmia? The class level open scores like AFIB, FLB, these are the noise, junctional, tremonacy, and all these things we have achieved. What are the precisions we have achieved? That is a 80%. Recall is 78%. F1 is 77%. That the author has achieved in this particular paper or the research. So, what are the challenges that we are facing right now in dealing the deep learning type of things? That is DL to be used as a tool. We can't use like what we use in stats, particularly in the stats type of thing. We have to use DL as such in that pattern. Means the unbalanced classes. The example we have taken for non-cancerous, then cancer example. I mean, there are many type of unbalanced classes we are dealing with nowadays. Data creation and annotation. This is the particular type of problem. We have a lot of data, image data in medical imaging or medical healthcare sector. We have a lot of data, but creation of a particular type of data and annotation means the authentication of data is more mean cubism. Why we are doing what the things we have to take into account. We have to see the doctors also. We have to take the particular authentication of the doctors that the data is genuine or not. Means cubism process. It is a cubism process, and experts don't always agree. What you are predicting, the examiner or the clinical practitioners will not uh, uh, agree with you. Then it is a conflict between the predictors and the doctors. Variability of the data, like example, there are variety of data available. Uncertainty in the data means the images what we are getting in India, what are the cancerous type of symptoms we are getting here might be different from the people who are living in other regions of the world. So how to leverage data from different sources? That is also a challenge what we are facing in deep learning. Means the images and journal patient information, how we leverage data from different sources into a one so that we can predict from all the data simultaneously. So what are the conclusion and key takeaways from this particular lecture that we will discuss? Like one is machine and deep learning is here to stay, but you have to beware of the things. Second is cross area collaboration is essential. We have to collaborate. Deep learning individually can't do anything. We have to collaborate in different fields, means like in bioinformatics, in biotechnology, for the heart patient, for the heart, for eye surgeons. In every aspect of bioinformatics, we have to collaborate. Then only we can use a deep learning more precisely into the healthcare sector. Means data creation and sharing is the cornerstone for the success of deep learning in healthcare. Means we have to create authentic data and we have to share that data with all the researchers in the free domain on the open source, so that more and more researchers come up with their solutions for their particular disease. That's all for the lecture from the deep learning from my side. Now I am open for questions.
Yes. So firstly, thanks a lot, Dr. Gupta. It was very, very insightful. As myself being a very enthusiastic about learning machine learning, and I always pay so much of attention and always make sure that I read articles about what is happening in the field of technology and what is the future, right? One thing I would really like to share it with attendees also, that there is because because of the profile, I interact with many of the hiring managers, many of the people. The demand in the sector of healthcare, right? It has increased exponentially. The demand in terms of the like ML engineers, AI engineers, someone who could represent data, even data processing and cleaning, right? So the demand has been like it is unforeseen. Obviously, decades ago we didn't have that much of influx of engineers in the field of healthcare, but now it has been growing exponentially. So one line that you had already at the end, like it is here to stay, and
Yeah. Yes.
yeah,
Yes.
it is here to stay, and definitely it is. We can expect a lot of requirement. Many of these students they can take up healthcare as their in research. They can also take these subjects, and it is definitely going to be it is going to be helping and going to solve many problems that we have it today in terms of diseases. We are open for questions from all the attendees, right? People, please, you can type down your questions and we'll take one by one. And I do not see much of the questions here, but I will wait. Let's see few of the questions itself. And meanwhile, I had a question. I had one question from you, Dr. Gupta. You talked about the skin cancer, right? Probably when you were discussing about that. So it is geographically different. That's what you said at one point, that people from India might face a different severity of compared to someone living in Europe or some other country. So
Yes, Rohit. As I give you the example of Baddi area, the pollution might be there are a different type of pollution in Baddi, irrespective of the Ponta. This is the skin cancer is prone to the pollutant, and what are the organic substances present in the air. Might be Delhi is the worst case for the skin cancer because there are a number of pollutant available. But if you see the skin cancer in the upper region of Himachal Pradesh or in the European countries where the snow is more is there, so the skin cancer is not there. The skin cancer is the prone for the skin cancer is less. While we are working on the region where have the factories are more or something pollution is more.
okay. Insightful. I believe many of the people would be very happy to move to some colder places. Some clean air definitely would help, right? We have a question from Ayushi Gore, and she okay. This is a very interesting question. As we can see, we've been having a lot of debates on news channels, on other platforms as well. That is 5G technology, which is although it has been introduced around the world, while coming to India, will it be having some healthcare risks? So how does this technology would go? Do you have we would like your thoughts on that actually at this point. I believe Dr. Gupta have some technical issues. Okay, so I guess Dr. Gupta is going to be rejoining again, guys. Meanwhile, you guys can type down your questions, all the questions you have related to the program, related to anything related to what we have discussed about today, or are there any questions which are apart from this about the program, about the course that we have? We have a program, advanced certification program in artificial intelligence and machine learning, and we cover deep learning in our third module, which covers deep learning, and we have one of the projects. So we are working with IBM on that particular project, that is diagnosing cancer with image sensing. So that is a very interesting, and many of the students who can take that particular program, they can get a certificate from IBM for that particular algorithm if they want to work on that particular design. I guess Dr. Gupta, we have him again with us. He just had a technical issue. So, yeah, Dr. Gupta, are we audible?
Am I audible, Rohit, now?
Yes, indeed. So, actually, we lost you. We have a few questions that has come up for you, and a few of them are really interesting.
Yeah.
So, Ayushi, she wants to know the 5G technology. Is it of any health risk to humans? We're talking about birds a lot, but also to humans.
As per the research is conducted on the 5G, this is something a risk prone to the birds. You have seen around the towers and something else. The words which we are seeing in the previous time are eradicating right now, just because the use of ways but the 5G towers are using, and also the increase in cell used by channel it for the increased receptions. As they are increasing the channel bit for the reception perspective, the waves are also increasing. That is the a major concern for the birdies. So that is for my concern, from my perspective, yes, there is a health issues for the birds or the animals or even for the humans for the use of 5G, more 5G.
Okay, thanks for that answer. We have another question from Biswanath, and he's asking, what is the difference between human and machine image processing?
Human and machine image processor means, for as per the my concern, is the human is what we are seeing, we are processing that thing. Okay, but for the machine concern, what we are giving to the machine, what we are giving to the features to the machine, they are just depicting the features from that particular image. Means human can't see the features of the image in more detailed version as per the machine.
All
Might
right.
be hmm.
Okay, you want to talk about that? Please go ahead.
That's all from my side.
Okay,
Rohit.
got
This
it.
question is
All right. So we have another questions from Raj, and he wants to know what is data normalization and why do we need it?
Raj, that is a very good question. Why we need a data normalization? For example, we have a n number of data that is redundant, and that is means a duplicate data is available in the. You can we as we are keep aside for the image part. We take a simple database example. If we have a number of record that are duplicating right now, and certain records which are of no relevancy, then we have to normalize the data. We have to remove the duplicacy, we have to remove the redundancy from the data, we have to remove the noise from the data, so that we can work on a particular type of data. I mean, we have some labeled data to work on, uh, so that we can get the good accuracy. That is the particular point of data normalization. And why do we need it? To get the more accuracy and crisp results. Because in health sector we need a accuracy. Accuracy is more accuracy means more preciseness. Then only we can predict, we can uh, give our prediction model to the doctors. Only then, if our model is more precise and accurate, then only the clinical trials or the clinical doctors will accept our model.
Okay. We have Ajay asking us what is a neural network?
What is a neural network? A good question. Means a model on a human brain or a nervous system, you all know that is the neural network. Okay, so what is artificial neural network means? ANN are comprised of more layers. Layers mean what we are working on the layer, containing an input layer, one or more hidden layers. As we seen in the example of the neural network, we have we have hidden layers that are pre-processing those particular input into the so get the output. Each node or artificial neuron connect to another or associated weight or threshold. We have the weight associated with each of the node, particular weight and the threshold value. Means if a range reaches certain extent, then the neuron will deactivate it. So what is the neural network in machine learning? Why we use machine learning neural network? Means I have told you the hidden layers or input layers or output layers that tries to mimic the work of human brains. Means how human brain works. We get the input from our eyes. Okay, we have the input layers in our brain that pre-process the data, that then it will give you the exact output, what we are seeing right now, what we are talking right now, how you are hearing, and it all done by the brain activities. That is the neural network in perspective to machine learning.